So now we're going to look at the inverse of this second form. So I have the inverse Laplace transform e to the negative as f of s. And if it goes back to the f of t minus a times the unit step of t minus a. So again, that minus a, as it shifts, and we have to make sure that we get them back in there. So our first example, so we have e to the negative pi over 2s over s squared plus 9. So we're going to get our a term from that exponent. And remember, it's negative a, so that's a is equal to pi over 2. So the shift, when you have that t minus a, that's just going to give me the unit step of t minus pi over 2. Now, the rest is, before we do the shift, we just have that s squared plus 9. So that is really similar to k over s squared plus k squared, where k is equal to 3. So we're missing that 3 out front. 3 in the numerator, so I'm going to have to put that in. So I'm just going to pull a 1/3 out front. So that gives me t minus pi over 2. And then this inverse Laplace, that is the form for sine. So I get sine of 3 times t minus pi over 2. Okay. So the steps to find the inverse is, first we need to identify the e to the negative as. And then we're going to just take out the unit step part, u of t minus a. And then we have to just look at the inverse Laplace and make sure that it matches. So we have to make sure that we are in that t minus a part, like we did in this up here. We still have these that are matching inside this argument. Alright, so that was one of the first things when we were doing these, before we were doing the inverse, we had to make sure that those arguments matched. So I want to find the Laplace inverse of 2s over e to the s times s squared plus 2. So that e to the s, I need to kind of pull that apart and separate it so I can identify the a. So inverse Laplace, instead of having that e to the s down there, I'm going to just rewrite it separately as e to the negative s. And then I have 2s and s squared plus 2. So a is going to equal to 1. So I get 2 minus 1. That 2 I just want to pull out, because then I have the form s over s squared plus k squared. So k squared is 2.